Hello everyone, welcome to my channel Brainy Equation. Today we are going to solve a great challenge. We have an exponential equation. The exponential equation is 2 to the power x is equal to x, and we have to calculate the value of x here. So let's start this challenge. Let's start the challenge. So we will write the exponential equation 2 to the power x is equal to x. We will take natural log on both sides, on left hand side and on right hand side. So we are going to take the natural log 2 to the power x is equal to natural log x. So here we are going to use a very well-known property of natural log. This property is very common about the natural log. So here natural log a to the power b, then we can write this b will shift here. So we will write b times ln a. So here we will use the same property. X will write here x natural log 2 is equal to natural log x. So now in the next step, we will divide both sides with the x. Divide both sides by x. So because we want to bring variables on one side and the constant on one side, so divide x natural log 2 over x is equal to natural log x over x. So here in our next step, we will write x will cancel out with x and we will get natural log 2. Natural log 2 is equal to natural log x over x. So we can write natural log x over x on the left hand side. Natural log x over x is equal to natural log 2. So from here, we know another property that we can plug in the value of x. And what is the value of x actually? We know that the x is, here x, we can write x as e to the power x is equal to e to the power ln x. So here we will plug in the value of x. Natural log x over e to the power natural log x, e to the power natural log x to natural log 2. So in our next step, we will use another property. Another property that is, if we have 1 over a to the power b, then it is equal to a to the power minus b. The power will become negative. So here we will use this property, natural log x over times, because we have shifted e up there. So e minus natural log x is equal to natural log 2. So in our next step, now remember, recall the lambda w function, that if we have expression of the type a times e to the power a, then we apply the lambda w function on it. Then we will get a. So here we are going to use the lambda w function. We want to create the same expression. So we will make our expression so that we can apply the lambda w function. So here we have the minus sign, so we will multiply minus on both sides. So here minus ln x is equal to, in times e to the power natural log x is equal to natural log 2 minus natural log 2. So in our next step, we have the same structure as we wanted to create to apply a lambda w function. So apply lambda w function minus natural log x times e to the power minus natural log x is equal to lambda w function minus natural log 2. So in our next step, we have minus natural log x, it is a, and e to the power minus natural log x, it is a. So we will write minus negative sign minus natural log x is equal to lambda w function minus natural log 2. So here we have a negative sign. We want to eliminate this negative sign. So we will multiply minus 1 on both sides, left hand side and our right hand side. So we will get here natural log x is equal to minus lambda w function natural log 2. Natural log 2. So here in our next step, we can take base e. We will write base e to the power ln natural log x is equal to my e to the power minus lambda w function natural log minus natural log 2. So here we know that we have used this property previously in our previous step. X is equal to natural log e to the power natural log x. So we will plug in the value of e to the power ln x, that is x is equal to e to the power minus lambda w function minus natural log 2. Here we can write x is equal to 1 over e to the power lambda w function minus natural log 2. Here we have a positive sign. So it is the answer. It is the value of x. It is our root. So if we want to look at the root, if we discuss it, and if we want to find out the approximate value of the root, so if we want to calculate approximately lambda w function my parenthesis minus natural log 2, if we use calculator to find out its approximate value, then it does not exist actually. It does not exist. So lambda w function minus natural log 2 does not exist if we use calculator to find out its value. So it means does not exist. It means the lambda w function minus natural log 2, it is the complex root. It is the complex value. It's not a real value. It's a complex value. Complex value. So geometrically, we will draw the graph of the exponential equation. Y-axis, x-axis. So the exponential equation is 2 to the power x is equal to x. So 2 to the power x, the exponential equation, for exponential equation, the graph is like this. And the other function is the linear function, so its graph is a straight line. So we have seen that there is no point of intersection. So we have no point of intersection and we have the value of x that is not a real value, it is a complex value. So we have a complex solution, and in this solution we have no point of intersection and it is a complex solution. So it is all about this challenge. It is not an easy challenge, it's a complicated challenge for the students. So this is all about this question. Don't forget the steps that we have used in solving this question. So you can also share your solutions in the comment section. We will check our solutions. So it is all about this question. Thanks for watching. Don't forget to subscribe my channel for more solutions and videos like this. Bye.